Most undoubtedly, the semiconductor is a key component for literally the very backbones that run everything today. Both in space as well as cyber, and cyber and space in turn also kind of ride on each other. The semiconductor is at the base of everything, but then it's everywhere. It's in the weapon. It's in a navigation and guidance. It's in a propulsion. It's in every control. Everything that uses computing today uses a semiconductor. So it is something that you require at massive scale in terms of numbers. That's number one. Number two, it's also our ability to fabricate to the user demand. So tailoring and customization. Okay. There are, for example, sensors. Okay. Sensors is one area where we don't make the detectors because we don't make the chips. Another thing to remember is, our struggle with the semiconductor thing, and we have started with a lot of lag, is that, like the professor brought out just now, we are still at 28, and people are talking about far, far thinner kind of, nanometric parameters here. And so we still have a long way to go. So how do we do this? How do we leverage it? Number one, we have to crack the basic technologies. How we do that? Different people in the world have done it differently. We have to collaborate. We may have JVs. We may do whatever we require, transfers of technologies, wherever that can come from. And like all critical technologies, there are denial regimes, very subtle denial regimes in place. There will always be, ways to make you struggle harder. To give you an example from space, Gagarin went up in space in 1961. Right? In 2025, we still do not have the technologies which can make human spaceflight dependable. Right? So no one shares the niche technologies. You have to struggle and get them yourself. It's the same as nuclear technology. Nobody shares it. So we have to scale. We need much, much more in terms of the infusion of capital. Also in terms of talent. We have to bring back some of our people. And that's something that I'm looking at space and several aspects of the cyber world. And we just have so much of our talent which is elsewhere. And some of them are coming back because of the increasing entrepreneurial opportunities. And some of them are coming back because India is looking like a much better destination when they were, in economies which have started to decline. So that is one way. But unless we have the appropriate mix of talent, right, technology, manufacturing capacities, and they must be distributed. They must be in multiple different areas. Gujarat is going in for a big way also with the Tatas there when it comes to the chip. And so is the Northeast, which is very, very encouraging. All of this we are going to have to do at scale. And I won't stop at the chip. It's not only the chip. Chip is only one example of a variety of different niche technologies which we need at scale. For example, if you look at the Navik chip, okay, if you look at indigenization of the PNT technologies, the GNSS technologies in country, because right now there's nobody who makes them in the required quantities. That's why we don't have user devices. We have satellites spinning in space, but we don't have the user devices. By this time, the entire country should have been flush with Navik devices. They're not there, right? It's only the DRDO and DHL and a few other small, niche strategic users who are tapping into it because we don't make the chip. And we need millions of these because they're going to go into all of your IoT networks and devices. They're going to go into just thousands of platforms. Every vehicle is supposed to have one. The guided weapons are going to have them. Every rocket will have. We're talking millions. So that's the kind of scales. But do we have the manufacturing capacities at the moment? No. So these are areas we need to focus if we want to leverage the growing or the imminent strengths in chip manufacture